In this video, I'd like to continue talking about multiplying complex numbers graphically. And you can see here, I've copied down the formula for multiplying two complex numbers in their polar forms. And remember, polar form just tells us the magnitude of the complex number and the direction on the complex plane that that number is in, where the angle, theta 1 in this case, measures the angle relative to the positive real axes. And when we multiply two complex numbers in polar form, we've seen in an earlier video that we can simplify this into an expression where we have the product of the magnitudes, or the distance from the origin of each complex number. These are multiplied together. And we have essentially the sum of the angles inside both the sine and the cosine function. And keep in mind that the way to interpret this formula is that when multiplying two complex numbers, we multiply their magnitudes and we add their angles. And if we want, we can even consider this product to be a complex number on its own. Let's call it Z3, where this right here, the product of the two magnitudes, this would be the magnitude of Z3. And the sum of these angles, we can consider this to be the angle for this complex number Z3. So this theta 3 is really just the sum of theta 1 and theta 2, the two angles from these complex numbers. So we multiply the magnitudes and we add the angles. And for this example problem, we have a complex number z right here, and we're going to multiply it by the complex number 1 plus I. So let's start by plotting this point. We go over 1 and then up 1 in the imaginary direction. So we have this number right here. And this complex number, if we draw a line from the origin to that point, we can see it has an angle of 45 degrees. Whenever it's the same real and imaginary part and they're both positive, it's going to split the imaginary axis and the real axis in the middle. So we get this 45-degree angle. And if we want, we can calculate the magnitude using the formula for the magnitude of a complex number, that it's the square root of the real part squared plus the imaginary part squared. And since each of these are 1, we get the square root of 1 plus 1, or root 2, for the magnitude. And we have this complex number z, which, if we draw a line to that, and it will get a little bit messy since we're going to be overlapping here, this magnitude we can see is length 3, but it has the same angle as this complex number here. So it also has an angle of 45 degrees. And based on this formula, we are going to add the two angles, and let's write this down. We have z multiplied by 1 plus I, and this will have an angle of 45 degrees plus 45 degrees, so we're at 90 degrees. And we're going to multiply the two magnitudes, 3 multiplied by root 2. And if we want, we can put this into a calculator, but root 2 is approximately 1.41. And since we know the angle will be 90, that narrows it down to 2 possible points. But notice that B is a distance of 3 from the origin, and we know that our magnitude should be 3 times the square root of 2. It should be bigger than 3. And that leaves us point A. So A is the only possibility that makes sense. And if we match this up with the decimal for 3 root 2, it does make sense that it is right about here.